with substitution. Does anybody remember kind of like the process for that? Or if you want to look down the page, these questions are kind of set up to be solved using substitution. Does anybody remember what you do?
You have like a equation or variable nicely, you can just plug that equation.
Perfect. Okay, so basically what you're doing is you're looking for a variable alone in one equation. Or maybe it's a situation where it would be just really easy to get a variable alone. So you're looking for, and it could be X, it could be Y, we could have different variables. But just look for one of the variables to be by itself or easy to get by itself. And then you just sub that into the other equation. So we're looking for a variable either all by itself or maybe easy to get by itself. And then whatever that variable is equal to, substitute that in for that variable in the other equation. So, for example, first one right here, looking for my variable by itself, and actually either one of these equations, it would be, the first one's already got y by itself, but the second one, it would be just one step to get y by itself if I wanted to do that. But all you're looking for, just look for a variable by itself, and then all you're going to do is replace or substitute what that variable equals in for that variable in the other equation. That's all you got to do. Now, this first one here, this one, there's no distributive property or anything because it's just negative 5x plus y. So I'm just going to copy in place of the y. It's positive 2x and then minus 3. And then in that second equation, it's just equal to 6. And then you're just going to go from there, just normal algebra steps. So I would combine my like terms here, get negative 3x minus 3 equals 6. We're going to do two steps. We're going to add 3. And then I get negative 3x equals 9. Divide by negative 3 to get the x alone. And x is going to end up being negative 3 there. Now, am I done with the problem? Like, what else? Just raise your hand and tell me, like, what else do I have to do? Yeah. You have to find the value of y. Okay, how would I do that? Perfect. Does it matter which one? Nope. You just have to substitute. You basically have half your answer here, right? Because you're telling me, these are two lines, you're telling me where they're going to run into each other in the coordinate plane. So you just have the x coordinate. We need the y coordinate. You can plug this in to either of those two equations. A lot of times with substitution, though, I'll be honest with you, one of the equations might be a little bit faster than the other. In this one, I'd probably say, hey, let's just plug it into that first equation because then I've got the variable y, which is what I'm trying to figure out, already by itself. And we could just type that in the calculator or you simplify it by hand, whatever's easier for you. This would end up with y being negative 9. Okay. Now, on a test or quiz, I totally don't care as long as you tell me both of those numbers, how you write that format. But I will tell you, because the homework today is on the Math Excel, they do have you write it as coordinate points. So where would these two lines intersect? It would be the point negative 3, negative 9. X coordinate goes first and y coordinate goes second. So that's how you want to type your answers when you're working on the homework assignment today. All right, let's look at the next one's a little bit weird, but you could use substitution on this next one. So I've got negative 6, and that's equal to 3x minus 6y. And then the second equation, I got x minus 5y equals 4. If I wanted to tackle this one and use substitution, okay, but just raise your hand and tell me, like, what would you do? Perfect. The second equation, just one step to get x by itself, I'm just going to add 5y. Now, totally up to you. I usually go ahead, if I have a term that has a variable, I write that right after the equal sign, and I would just slide that positive 4 over. But you could write 4 plus 5y. That would be exactly the same thing. So just manipulating that second equation for our purposes. Then we have our variable 11. And then all we have to do, take this and put this in place of x in the first equation. Now, just make sure you put it in for the correct variable because I screw that up sometimes. But I'm going to sub this in that first equation. So it's 3x. So all you got to do is just, when you put the 3, just put parentheses, and then x is equal to 5y plus 4, substituting that in. And I'm just going to close the parentheses, and I'm not going to forget to write the rest of that equation, which is just minus 6y. And then from there, this is a little bit more algebra. We're going to have to do a distributive property here. So this is going to be 15y plus 12 minus 6y. And if it were me, I'd go ahead and combine my like terms. I got 15y's minus 6y, so I've got 9y's there plus 12. And then I'm going to move the 12. So we get negative 18 is equal to 9y. And then divide by 9. Y should end up being negative 2. And then just remember, you only have half of your answer there. Now, you can use either one of the equations in the original system, or you can use the one that we just created to help us do the substitution. I'd probably plug that in right there, because then that's already solved for x. All we have to do, 5 times negative 2 plus 4. And then, of course, you guys can use your calculator to do this by hand. This would be negative 10 plus 4, so that would end up with our x coordinate being negative 6. And as long as you got both, I'm good with that, but just for today, when you do your answers, the x value has to go first in the coordinates, so it would be negative 6, negative 2. If we were to graph those two on the coordinate plane, that's the point. Those two lines would run into each other. Is anybody having a question? Now, everyone's favorite here, some fractions, yay. Sorry, that line's not very straight. Okay. Now, I've got y equals 4/5 x plus 3/5, and I've got y equals 5/8 x plus 2. If I wanted to use substitution here, how might you start that problem out? Like, what would you maybe write down? Substitute the x plus 2 into the y. For sure. And actually, this could go either way, because both of them are set equal to y. So if they're both equal to y, they're both equal to each other. So I could take the bottom one and put it into the top, or I could take the top one and put it into the bottom, whichever way you want to do it. And so we'd have, basically what we're doing when we're doing the substitution, we're taking two different equations with two different variables, and we're creating one equation that just has one variable, so that way we're able to solve for it. All right, now I'm looking at this, probably rolling my eyes going, Miss Schroeder, you're such a brat, look at all these fractions, I don't want to deal with this. In this problem, I would tell you, if you wanted to write the decimal for each one of these, that wouldn't be bad to do. There's no repeating decimals or anything like that. What I would maybe also recommend, though, if you want to work with the fractions, I would recommend let's just get rid of all the fractions. Can anybody think of something I could do in that equation to get rid of all the fractions in the problem? Maybe make it easier to work with? Yeah. That's what I would do. Multiply. So you got 8 and 5 in your denominators, right? This is just a plain 2, but if you can think of a number these two will both go into, and that I would use 40, but you could use like 80, or you could use other numbers, as long as 5 and 8 go into them. I'm going to multiply everybody by 40. So everybody, including the 2. Now, when you do that, just multiply 40 by the top of the fraction, okay? So I'm going to have 5 times 40 is going to be 200. So the bottom would stay the same, because the bottom would just get multiplied by 1. If you multiplied the top and the bottom by 40, then you're not multiplying by 40, you're multiplying by 1. So with an x next to this. Okay, now 2 times 40 is 80. 4 times 40 would be 160 over 5. That would have an x next to it. 3 times 40 would be 120. And as long as you've picked a number that both of those denominators go into, those fractions should totally just disappear. So if I do 200 divided by 8, I'm pretty sure that's 25. Let's see. Yes. Okay, so this is 25x plus 80. 160 divided by 5, I think is, yep, 32. And that's got an x attached to it. And then 120 divided by 5 is going to give you 24. And that equation is a lot more manageable than dealing with those fractions. So you could always clear a fraction. We did that in our first unit in a couple of equations. It's a really useful skill to have if you want to get rid of those. Okay, now, totally up to you. If it's me, I like to try to keep my variable positive, so I would subtract 25x from both sides, and I'm just going to do this right in the same step because I wrote too big, but I'm going to move the positive 24 here. That'll put, the way I wrote my equation, that'll put all my numbers on the left and all my variables on the right. So I'm going to come over here. I'm going to end up with, what would that be? 56 equals 7x. And then I'm just going to divide by 7. This actually ends up being a nice number. X is just going to be 8. And then completely up to you, but you can plug that 8 back into either one of the equations in the original problem. If it's me, I might just recommend plugging it into the second one. And the reason for that, that denominator is 8. So if I do 5/8 times 8, that denominator and that 8 will cancel each other out. And this will actually just end up being y equals 5 plus 2. And then the y value there is going to be 7. So if I had to type my answer, then you just would type 8 comma 7. And that would be, if we had graphed those, that would be the point those have in common. Is anybody having a question? Okay, now, the other two I'm going to do down here, these are also substitutions set up to do that, but we saw this in our last lesson that you don't always have a solution, or you might have infinite solutions, so I wanted to show you what that would look like algebraically. So both of these are kind of set up so you might try to use substitution as a way to solve. I would just take in that first equation what y equals, and I'm going to substitute that in place of y in the second equation here. So if I do that, it's just plus y. So I'm just literally going to copy the minus 3x minus 8. Nothing's going to change there, and that's equal to 10. So what will happen if you get one of these special cases is the variables will actually cancel out. That did not happen on any of the questions. We had x equals something, y equals something. Here what's going to happen when I do that substitution, 3x minus 3x, those add up to 0. That cancels those out. And so if your variables are canceled out, you're going to end up with a special case. And so you got to ask yourself what's going on with what you have left. So what I have left here is negative 8 equals 10, no variable. What do you think is going on there if I get negative 8 equals 10? Ellie, what do you think? Right. This is not true. If it's not true, that means just no solution. What it really means too, if we were to look at this on the graph, these two are going to be, they would be parallel lines is what it would be. We're not looking at a graph, so that might not be super obvious, but if your variables cancel out, you get something that's not true, like 3 equals negative 20. Not true, that just means that those lines were parallel, there's not going to be a solution. All right, now here's the other one you can run into. So in this one, I've got x by itself, 5y plus 3, and I'm going to substitute that in place of x in that other equation. So here we'd have to do a little distributive property. So I've got 4x in place of x. I'm going to write and substitute in the 5y plus 3 minus 21 equals 12. And then just a couple little steps here because we'll have to use a distributive property. So I got 20y. Make sure you multiply the 4 by that 5y and the 3 also inside those parentheses. Just be careful with that. Minus 20y equals 12. Now on this one, I got a positive 20y and a negative 20y on the same side. So those guys add up to 0. And I end up with 12 equals 12. What would my answer be if my variables are gone, but I've got something like that? This is infinite. If you end up with something that's true when you're solving a system, this is going to be the infinite solutions. It just means these two, and that's not noticeable to me when I look at those equations, but those two equations both represent the exact same y. All right, so not true, no solution. True, infinite solutions. If you get x equals something or y equals something, then you're going to have one solution. Is anybody having a question? Now, I've got word problems on the back. Everyone is thrilled to turn their paper over and see that. All right. Usually when you do a word problem, if I'm being honest with you, they're usually actually a little bit easier to solve. It's just a matter of setting them up that is the tricky part. So that's what we're going to do here on the back, is practice this. So this first question says we've got a company that spends $12,000 on equipment and they're going to make footballs. And it says it costs the company $9 to make every one of those footballs, and then they're going to sell them to the public for $25. So it says write and solve a system of equations to determine how many footballs the company has to make to break even. Do you guys know, what does break even mean, like in terms of business? Yeah. Yes, that's a good way to put it. You're remaking what you've spent. So basically, they've got this $12,000 in equipment, right? And it's still going to cost them money every time they produce a football, but eventually they're going to start turning a profit. So we're going to go to the place where they've basically paid off the equipment is what we're going to go to. All right, now these are always weird for people to set up. So I'm just going to kind of it feels like there's more than two variables, but there's really only two. All right, so I'm going to do the letter C just for cost. And I'm going to do F to represent each football. And it's going to represent kind of two different things in my equation. So one's going to be the cost to the company. The other equation, I'm going to do the cost to the customer. And for the company, it's going to be how many footballs they make. And for the customer, it's going to be how many footballs they buy. So there's going to be two separate equations here. All right, so let me do the cost to the company first. So they got to pay the $12,000 in their equipment, right? So the cost of the company, just $12,000 flat fee. And then I'm going to put plus, it costs them $9 for every football. So I would do something like 9F, or you can use different variables if you don't like my variables. Now, the cost to the customer, we're trying to see when these are equal. That's going to be your break-even point. The cost to the customer is just $25 for every football. So then this is tailor-made to use substitution. I would just substitute that right in there. So we're going to have 25F for every football, 12,000 plus 9 times our number of footballs. I would just subtract the 9 from both sides. And we'll get 16 times our number of footballs equals 12,000. I'm going to divide by 16. I'm trying to pay off this equipment. And you'd end up with 750. So to break even, to pay off their equipment, they're going to have to sell 750 footballs. And then let me ask you this. At that point, let's say I sold 750 footballs. Do I start making $25 on every football? How much money do I actually make after I break even? How much money do we make every football? Exactly, because it's still going to cost them $9 for every football they make. So really, after this point, their profit would be $16 on each one, not $25. Okay, does anybody have a question? All right, do a little geometry throwback here. All right. It says perimeter of a rectangular patio is 90 feet, right? So I'm just going to draw a little rectangle. So my perimeter, count up the outside edges, right, is 90. And it says the patio's length is 5 feet less than 4 times the width. All right, I'm just going to label my picture just really quickly. So I'll just call the shorter sides the width and the two longer sides the length. So if I do my perimeter, right, it's add up the sides. We'd have 2 widths and 2 lengths. But I actually know the perimeter from the directions is 90 feet. So just in general, that's a formula for perimeter. For this specific question, we're going to have 90 equals 2 widths plus 2 lengths. Okay. Now, what we're going to try to do is we're going to try to create an equation that only has one variable. So I only need one equation, one variable, but I need 2 equations with 2 variables to start. The other part of this is going to come from this. Patio's length is 5 feet less than 4 times the width. Okay, so I'm going to write L for length. How could I translate that the length is 5 feet less than 4 times the width? Perfect. Okay, be careful with this. I feel like whenever there's a less than, people will accidentally do like 5 minus 4W. It has to go 4W minus 5. Okay, now, here would be my lovely system. Now, is this how Miss Grody does this question? No, I do not like plug this in here. Here's how I do this question. I just think about this literally like I substitute it kind of into the picture. I don't actually do the algebraic substitution there. I just put this in the picture and I just go ahead and calculate the perimeter once I plugged in what the length was equal to. So here's all I do, or you can use substitution. If you want to use substitution, plug this in right here for the length. This will work too. Or if you want to just do it here, I just count how many W's I've got. I've got 1 here, 4 here, and 4 here. So you got 10 W's. And then I've got -5, -5. Just combining like terms. Sorry, that's going to give you -10. And I set that equal to the perimeter. If you want to actually use the system in the substitution, you are welcome to do that. We're going to get the same answer. I just kind of do it a little bit more visually, and I substitute the expression into my picture. So then, all I'm going to do here is going to add 10. So 10 times my width is going to be 100. So then the width, if you divide by 10 there, is actually going to be 10. This would be in feet, since our perimeter is in feet. And then all you got to do for your length, if you know the width is 10, you're just going to plug it in right there. So 4 times 10 would be what, 40? And then -5, so my length would be 35 feet. Anybody having a question? A couple different ways you could kind of do that problem. All right, now this last one is very tricky. So I'm going to ask you a question, and I promise I know you know this, but I want to just make sure. So this says a jar contains only nickels and dimes. Totally normal. I'm sure I have one of those somewhere at home. Okay. There are 3 times as many dimes as nickels in the jar. The amount of money in the jar is $9.80. How many of each type of coin do I have, right? All right, so I'm just going to use N for a nickel, and I'm going to use D for a dime. How many nickels and how many dimes I have. My question to you is, how much is a nickel worth? 5 cents. Okay, how do you write 5 cents? 0.05. Okay, somebody always writes 0.5, which is really, 0.5 would be 50 cents. And I have some 50-cent pieces at home, but I don't think they make them anymore. So 0.05. Just be really careful with that because that could really mess your problem up. And then you guys, I know, dimes are 10 cents. I don't need the 0 to follow the 1 there, but just to let you know. Now, on my first equation, I'm going to write money goes with money. So whatever the value is going to go with this $9.80. So here's how I would write this. 0.05 times every nickel plus you could just do 0.1. I'm just going to put the 0 so you can see I'm trying to represent 10 cents for every dime. So 5 cents for every nickel I have, 10 cents for every dime. If I plug those in, it's going to be $9.80. Now, this is very tricky, so hopefully I can explain this okay to you. It says there are 3 times as many dimes as nickels in the jar. Okay, don't think about the problem as a whole for a second. Just think about that sentence. There's 3 times as many dimes as nickels. So I'm just going to make something up. Let's say I had 5 nickels. How many dimes would you have? 15. Okay, what did you multiply there? 3 by nickels times 3. Okay, this always messes people up. So the 3 is closer to the word dimes, just grammatically, as many as. The 3 actually gets multiplied by the word at the end of the sentence. Always when you have that as many as. So 3 times as many dimes as nickels means I'm going to take my nickels and multiply that number by 3. So I'm going to say D for dimes is 3n. That always trips people up grammatically. I just try to make myself a little example up if I get stuck, but if you have, 4 times as many as whatever, that 3 is going to go by the word farthest away from it. Okay, now once you've got this is easy to set up. Just plug this in for your dimes in the other equation real quick. So we'd have 0.05 times our nickels plus 0.10 times 3 nickels, and then the 980. If you don't want to work with the decimals, you could multiply everybody by 100 here, but I'm just going to work with the decimals, no big deal if you have your calculator. So if I take 10 cents times 3, it's going to look like 30 cents. And add these guys up, we're going to get 0.35 times our number of nickels is equal to 980. Now, if I get a number that is not a nice number, I probably screwed something up because we can't have part of a nickel or part of a dime. So when you take that 980 and divide it by the 35 cents, you should get a whole number here. So this is going to give me 28 nickels. And then it's like a lot of these other questions. In the case where you can use substitution, a lot of times it's a little bit easier to plug that back in to one equation versus the other for a little bit less work. In that case, the dimes is just 3 times the number of nickels. So I would just take 28 times 3. Your dimes are going to be 84. Does anybody have a question? I do have the homework this